Hello. In this video we are going to study centroids. This will begin our discussion in the topic of statics. What is a centroid? The centroid is the object's center of gravity, or where the center of mass is. Graphically, we label it using this symbol. It's the point of applied force caused by acceleration due to gravity. Object is in a state of equilibrium if it's balanced along its centroid. So notice in the animation, this one is not balanced along its centroid, so it's not in equilibrium. But when we hold our finger at the centroid, we have balance. Why do we need the centroid location for statics? Well, the calculations that we do theoretically regarding the interaction of forces and how forces are working on an object are all derived from this centroid location. And in a few days here, we will have a lesson on free body diagrams, and we will make these free body diagrams based on the centroid location. You can determine a centroid location by utilizing the cross-section view of a three-dimensional object. Centroid location is determined by the object's line of symmetry. So for the triangle, we have a centroid, a line of symmetry, right along the middle here. So the centroid will be somewhere along this line. When an object has multiple lines of symmetry, as in this example of the square and the example of the circle, then the centroid's located at the intersection of the lines of symmetry. So on the square, we'll have a vertical line of symmetry, and we'll have a horizontal line of symmetry, and where those intersect is where we'll find the centroid. So pick any two diameters of the circle, and where they intersect, that's going to be your centroid. Here's some formulas that you might want to write down in your engineering notebook. They may be easy for you to remember, but trust me, later you're going to want to know these. The centroid of a square or a rectangle, whether it's square or rectangle, is located at a distance half of how high it is and halfway across, half of its base. So if you put an imaginary origin axis right here, then the x distance would be half of the base, as seen in this formula, and the y distance would be half of the height, as seen in this formula. For a triangle, it's a little bit different. The centroid of a right triangle is located at a third of the base and a third of its height. So to find this distance, the location of the centroid here, 1/3 of however long the base is. And for this y point, we're going to break the height up into thirds. And where those intersect, that's going to be our centroid. We can also find the centroid of a semicircle, and it's located at a distance of 4r divided by 3 pi. And it's very important when you look at this formula that you enter this into your calculator correctly. We're going to do 4 times the radius, and we're going to divide by 3 times pi. It's important that your pi is in the denominator of this fraction. That's how far away from the axis it is on its line of symmetry. So this axis that cuts the circle in half, whatever 4r divided by 3 pi is, that's how far away you'll go on your axis or your line of symmetry. So here, my radius is 2, so I'm going to substitute in a 2. So this will be 8 divided by 3 pi, and that gets me 0.849. So I'm going to go right along the line of symmetry, right down the middle, away from this axis that cuts the circle in half, 0.849.